Hello, this is our fifth lesson of the Twing Explore and Learn at Home. I'm Baha.
Hello everyone, my name is Ekin, and today we're going to explore more about computers and coding, as well as make some fantastic experiments. So let's start with today's presentation.
Okay, here we go.
All right, so as you may have noticed, throughout the week we were always giving away some prizes once you answer some of the questions we ask, and you can also search them online. So please go to twinscience.com, and there you can see our six of our robotics kits, and also the coding kit as well. So I mean, we're still encouraging the move and stay at home. So please be sure to check that out, and maybe you can find something that interests you. And other than that, then we have another question. Do you know what this sensor does, Baha?
I think this is a sensor that we talked about earlier this week. This is an ultrasound sensor, right?
Yes, you're right. So this here is an ultrasonic sensor, and I guess we talked about it, but although it wasn't our main subject back then, it was one of the topics we covered. So here I have another slide which explains how it works. So the scientists and engineers who designed this ultrasonic sensor were inspired by some animals in nature, like bats and dolphins and whales. So just like how they emit sound waves and then receive them back to calculate the distance between them and the object, most of the other vehicles and devices were made using this principle, such as submarines and ultrasonics as well. So do you have anything to add to this, Baha?
I think this is pretty self-explanatory. This is really interesting, and it's really nice to see this image to actually visualize how it actually works.
Okay, so we can move on to your side of the session then.
Yes. So today we're going to be working on a project that combines everything that we've done so far. We'll have loops, we'll have variables, we'll have inputs, and we will be doing something that's really new. So as you might see here, we have our twinner, and we also have this bottle of hand sanitizer that's right next to him. Let's actually rename these. So we have the twinner and the sanitizer. And we will be working on a project where we can actually have the twinner use some hand sanitizer on himself. And before we started, I drew a couple costumes that will be used in this experiment. So if we go to costumes, we have a second costume for the twinner where his hand is reaching out. So let's maybe call this press, because he's pressing the button on the sanitizer. And then this will be the normal one. And then if we look at the sanitizer, we also have two versions of it. We have the normal one, and then we have the pressed.
To code, right?
I missed that.
Now we have two objects to code.
Yes. So today will be the first time that we will have two separate objects that we will program, and we'll objects separately, and then we will see how they can work together. So we have two versions of this and two versions. this code, right? Let's maybe.
I guess Bahar will be right back in any minute now. So while we're waiting for him, we can just wrap up all the things we've done so far. And yes, he is back.
Yes, hi, I'm back. There was a tiny disconnection. So now we're back. So as I was just talking about, we will have the space key start this program. So let's put this block up here. And then when we're not doing anything, we want our twinner to be in the default state. So we will have him switch the costume to normal. This is how we're going to start. Everything will be in the default position, okay? And then maybe we can have him press on the sanitizer when we give him a type of input. So we talked about how we can press a button or click our mouse or do something like that as an input. So that's something that we can do. But something else that's really interesting is that something that we'll be looking at this one, touching mouse pointer. So do you have any idea what this block might be doing again?
Is it like an if block? So does it check if we're using the mouse pointer or so?
So as you can see, this has these, instead of the rounded edges, it actually has these triangular edges, so it's really sharp. And as you can see, these are actually some of our true false statements. So this touching mouse pointer is actually something that's either true or false, and it can check whether our mouse pointer is touching something or not. Maybe we can quickly look at how this works out. So let's have a loop so that we can check this constantly, and then I'll maybe see how it works to you. So if the mouse pointer is touching it, then we can maybe have him switch to costume 2, okay? The one where he's pressing on the sanitizer. And then we'll wait for a second so that we can clearly see what's going on. And then after that, he can go back to the default one, okay? So we press the space button, and then whenever my mouse pointer is on him, he actually touches, he reaches out and then touches the sanitizer. And then when it's not, he stops doing it. So if I go like this, he'll do that for a second, and then he'll retract his arm because it switches back to the original one. So that's an interesting type of input that we can also use here.
And then what about the sanitizer?
Yes, so if we want to program that, then we actually have to go to the sanitizer's own code screen. So to do that, we have to click here. Since we're going to be using some code that's similar, we can just copy what we have here and then work from that. So I'll just copy this and then paste it over here. And the name of the costume will be different, so let's check that. So now when my mouse pointer is on the sanitizer, once the code is running, it'll switch to the other version, as you can see. So if our mouse is on the twinner, his arm reaches out, and if our mouse is on the sanitizer, it gets pressed down. But these two cannot happen at the same time, right? We want them to happen simultaneously.
Yeah.
So something else that we can do is maybe change the input. For example, instead of having it check whether if it's touching the mouse pointer, we can maybe look at if the mouse key is being pressed. So we can change that. Oops. Let me just go back. We had a tiny problem. So we can check if the mouse is being pressed. So we can look at mouse down. So when the code is running, we can just click on the mouse to do this. Let's change that for both of them. So now when I click, when the code is running, we get this really cute animation where the twinner reaches out and then presses on the hand sanitizer. So this happens simultaneously in both of them. And what did you just say, Ken?
Mouse down mean? I missed that part.
I'm sorry, I had some hard time hearing what you just said. Could you repeat that?
I was asking the meaning of mouse down.
So mouse down checks whether the mouse key is being pressed at that moment.
Oh.
So when I click, it does this, and then when I stop clicking, it goes back to the original state. So it just checks whether the mouse key is being pushed down.
Oh, I see.
But there's something interesting that's happening here. So we can do this infinitely many times, right?
Yeah.
We can just do this again and again and again. And normally, we only have a finite amount of sanitizer that's in the bottle. There's a finite volume of it. So maybe we can do something to actually represent that.
So we're going to use variables, right?
Yes, exactly. We will have a variable, and let's call that volume.
Mm-hmm.
So we have this variable called volume, and we can see up there. And let's set that to, for example, 100. We'll have 100 milliliters of sanitizer whenever we start the program.
Mm-hmm.
So when we run, we have 100 volume. But whenever we run the code, whenever I press this, the volume does not change. So we need to change the volume every time this happens. How do you think we can do that?
We can assign a new number to our volume.
Yes, maybe we can change the volume every time it's being pressed. So maybe he gets 10 milliliters of the sanitizer every time he presses it. So we'll have it changed by -10 every time we do this. So let's run the code again, and let's see. So the volume goes down every time we press it. Yeah. Let's see what happens if we continue on doing this. So according to the variable, we currently have no hand sanitizer left, so we should not be able to do it. But when I press it, we actually get to a negative number. We don't want that to happen, right?
So are you going to use the repeat until block? Repeat until. That's
a really nice idea. So we can repeat until the volume is less than or equal to 0, right?
Uh-huh.
So instead of this forever loop, let's do that. Let's replace that with a repeat until block. So we don't represent that. Do you have an idea?
What did you just say?
So we don't have a less than or equal to block. So how do you think we can represent that with what we have here?
I guess we can use the OR block.
Yes, that's a really nice idea. So if it's equal to 0 or less than 0, that would be one way of looking at it. So we will repeat until the volume is equal to or less than 0. Let's see if this works. Let's plug all of these in and see what happens. Let's rerun the code. So it works perfectly well for now. So currently we have no sanitizer left. So when we try to press it, we actually do not get any sanitizer out. So we don't really get any of it out. So that works. That's one way of doing it. Another way of representing it might actually be using the not block. If it's not greater than 0, then it has to be less than or equal to 0, right?
You're right.
So maybe we can try that and see. So let's maybe see if that works. We'll get rid of these. So now, when we try this, we can go all the way to 0 volume, and then we again cannot get any sanitizer out. But maybe there's something else that we can do. So normally when he tries to press it, maybe we can adjust it so that the bottle itself collapses, but we don't get any of the sanitizer out. So we can maybe work on a third costume that we can use. So let's duplicate this and erase these sanitizer blobs. And we'll call this costume empty. So now we have 3 different possible. We still have 2 taking this. Then we will maybe we have 2 different cases that we can see. So if it's greater than 0, this will happen. If it's not, something else will happen. So how do you think we can do that? Maybe we can use an if-else block. What do you say?
Right.
So let's maybe replace this repeat until block with the forever loop, and then use an if then else in there. So if it's not greater than 0, well, actually, if it is greater than 0, we will this, right? We will have this here. So if it's not greater than 0 and the mouse is pressed, then we will have the empty one. And since we don't have any sanitizer left, we can't change it. So let's try that. So I'm running the code right now, and then I can press this button again and again until we run dry. And let's see what happens then. So as you can see, we can still press it, but we won't have any of the liquid that comes out of it. And the volume stays constant at 0. So this is a really fun way to actually use everything that we learned about this week so far. We have our inputs, and that we click our mouses and then we use a space key to run the code. We use multiple costumes to represent different situations in these sprites. We have 2 different sprites that we're coding independent of each other. We have our loops that we use to constantly check whether we're getting input. We are using the variable to see if we have any sanitizer left. And we can also adjust this value of the sanitizer to change the value accordingly so that it's something realistic. So this was something really.
Also use functions as well, right?
Oh yes, maybe we can use a function here as well. And but since we don't really have chunks of code that's repeated, maybe using a function here wouldn't be as practical. So that's also something important that you should consider. Just because you know how to do something doesn't mean you necessarily have to use that in your code. If it's not helpful, it may be a better idea to simply not include that. I hope you'll do many projects where you'll have the opportunity to include all of these different stuff anyway. So don't push yourself to put more in there than it needs to have. Because if you do try to force some unnecessary stuff into your code, it'll just be a bloated mess that probably won't work as efficiently as you want it to. So it's always a nice idea to keep things simple and use what you need to use and don't really include what can be considered unnecessary. So I think you also have another experiment for us, again.
Yes, you're right. If you're done, we can move on to that one. So
Yes, let's see what you have for us today.
here I have a candle again. Let me see if I can show you on the table. So as you can see, here I have a candle and I'm going to, oops. So Baham, I'm going to make a magic trick. Are you ready?
Yes, I am.
So as you can see, now it's all lit, but once I close my, put a gloss above it, now it's gone.
Wow. How does that work?
So lighting something up is can be thought of as combustion reaction.
Mm-hmm.
So combustion reaction is when you have oxygen and a material that lights off, and also something to some of them. So when you have all of these three components, combustion can occur anytime.
Mm-hmm.
And when firefighters are using, like, they don't have enough cases to put fires up, but they're using something else. So we're going to see how they do it. So here I have a few pinches of baking soda, and I'm going to add some vinegar.
Oh, let's see what happens.
You can see there are bubbles.
Yes. What are those bubbles?
We'll see. So let me just light my candle up again.
Wow.
I didn't, I didn't even pour some of this mixture onto it, but it still manages to put it out. So
Wow.
when
How
I
does this happen?
mix vinegar and baking soda, it creates a chemical reaction here, and carbon dioxide is formed. So we can see the evidence of this carbon dioxide in these bubbles.
Mm-hmm.
As you can see, and I was trying to cover on top of it to not allow it to escape, not allow the gas to escape. But carbon dioxide is a very heavy gas, so when when I pour this on top of my candle, so it is affected by the gravity, and since it's heavier than the air we breathe or the oxygen we breathe, pouring the heavy carbon dioxide gas over the flame pushes away the oxygen, around the candle and causes the fire to go out due to lack of oxygen. As I said, combustion occurs when heat and oxygen fuel are present. So me pouring this onto this candle allows the oxygen to get removed by the side and allows me to put out the fire. So let's try it again. Right.
Wow, that's so cool.
We encourage you to check this experiment out on our app Twing, and maybe you'll do something even more amazing than we are doing right now.
Yes, so what you mentioned was that combustion is a reaction with oxygen. So I know that when I breathe in, my body takes the oxygen from the air and turns it into carbon dioxide. So does it mean that there's actually combustion happening inside my body?
Oh, that's a good question, but I mean, that's not combustion exactly, because combustion is something lighting off, something that adds heat, and it happens when there is oxygen as well as fuel. So maybe
fun fact, that is actually combustion. Chemically speaking, any oxygen reaction that produces heat is a combustion reaction, and your body does produce heat when this is happening. Combustion in our daily use of the word refers to reactions that produce fire, but fire isn't necessary in a combustion reaction. So even our body has these tiny combustion reactions. A piece of metal that's oxidizing, turning into maybe rust, is actually a combustion reaction. So the concept of combustion is something that's really interesting and it's much deeper than what we actually assume it to be. So the word combustion that we use in our daily life represents some reactions that are combustion reactions, but it doesn't represent all of them. So that's something interesting that you may maybe research on your own.
Thank you, Val.
So after completing this experiment, you can certainly upload that on Twing. And we are also really interested in seeing what kinds of codes that you write and what kind of projects that you can complete now that you've learned all of these different coding principles and you've learned how to bring them all together to create an interesting new fun project. We will be continuing these lessons next week on Monday. And I hope that you'll have lots of fun working on these experiments until then.
So see you guys.
Bye.